So welcome everyone to this Sunday's live stream where we're doing interaction on like a new level. So what's planned today is we're going to take a look at a bunch of different prints like this one, which doesn't look that spectacular, and we'll try to figure out what's wrong with them, how we can improve them, and which settings to change on your printer, which hardware modifications to make, and all that sort of stuff. Yes. So the way this is, the way I've imagined this is going to work. So if you know me on Twitter, I'm at Toms3dp on Twitter. If you tweet your a crisp, sharp image of your prints at Toms3dp using the hashtag 3DSenpai, that's what's going to show up on this screen. Hopefully, I've got a lot of windows to juggle today. It's like yeah, it's pretty interesting. But anyways, that's like the... Am I clipping? This thing is blinking. I'm hoping not. That's like the idea today. So looking at your prints and trying to figure out how we can improve them. So before we get into that, I'm going to give you guys a second to tweet your pictures. Before we get into that, I want to talk about like some of the things that generally impact your print results. There's like a bunch of different things that I see as a recurring topic. So starting out, well, I've made a list. I've actually prepared for this, believe it or not. Let's see if I can actually find it. There it is. Right, let's grab a printer. Let's actually grab whatever. Let's grab the Lulzbot Mini. Because like it doesn't matter which one we show this on. I just want some sort of machine to demonstrate some stuff with. So, common machine issues. So, prepared, who are you? I'm the same guy as always. Now, there are two different classes of print quality issues that you're typically seeing. So, the first one I'd classify as, either it works or it doesn't. That would be something like belts skipping, like resonances, or belts or motor skipping, like your hotend clogging up because it's either a bad design or there's something wrong with the setup. Otherwise, that's like the black and white issues. Either your stuff works or it doesn't. Then the others are like, yeah, generally everything works, everything is in a working condition, but there is some tuning to be done to get it up to a level where it's actually like really, really nice. So if I switch over to, I mean, yeah, I am prepared. I just keep forgetting which buttons to press. That's the other thing. So yeah, this is the first print from the Hobby King Fabricator Mini. So there are obviously a few things wrong with it. First of all, the most obvious one is right here. There's a bunch of strings hanging down. There's a bunch of layers that didn't stick to the previous one. There's also a bunch of curling happening, and most of the quality issues on this print are actually stemming from the fact that this machine doesn't have a part cooling fan, and that would be like number one. That most printers get right. Most printers manage to get this relatively well in check. I don't know how much you're going to be able to see this, but typically your 3D printer, if it's like a new generation one with an all metal hotend, is going to have two fans, one to cool the hotend and one to cool the part itself. So this one just cools the upper half of the hotend, and this one actually blows air over the printed part. And you might be able to tell this one isn't really particularly well set up. Let's actually get this camera in here as well, because I think I can get a better angle. This is all live and not pre-recorded, just in case someone starts asking again. Let's switch over here. Yep. So because I put a different hotend into this Lulzbot Mini, this part cooling fan right here, it ends right there, and then sort of has to blow its air like these 2 or 3 centimeters down onto the part. This isn't ideal, and this doesn't work out particularly well. So ideally you want that fan outlet. There's a slit down here might be able to pick up by the camera, a slit down here where the air exits. Ideally, you want that as close to the nozzle as possible and just cooling, as long as the PLA print. You know, PLA is really sensitive to that. You just want that cooled instantly, effectively. And that is like part or issue number one on this one. The second part of that is, my camera's focused right there. That's a skipped step, or that's quite a bit of a skipped step. You can see the ridge up here is actually offset to this bottom one by quite a bit. That is, well, typically it's one of two things. Either your belt tension is wrong. So right here, these belts are, I don't know if you can hear that, these belts are properly tensioned. I think I actually retensioned these or something. No, this one doesn't have belt tensioning on it, but yeah, you might be able to hear that. These belts are properly tensioned. It's really hard to over-tension belts. The only thing that's going to happen if you actually put too much tension on them is the motor bearings are going to wear out, and you know, if you have weak motors, they might actually skip. But it's always better to have belts that are over-tensioned instead of being under-tensioned, because then things like, you know, the belt actually skipping on the pulley can happen, plus you will have backlash. This machine actually suffers horribly from that, the Dynamo 3D, because it doesn't have any sort of belt tensioning, and it has looped belts, so continuous belts and not ones that you could pull on the ends. And you can see that in the prints. Let's actually show this one as well. Right there. So that's one of the tunable issues, I'd say. So if you look at the sharp corners here, you can actually see it from all directions. Wow, this is hard. Yeah, there you go. There's the reflection I wanted to go for. So you can see pretty horrible ripples and overswings on all of the hard corners. And that's just because the mechanics overshoot quite a bit when they actually hit a corner, and instead of, you know, making that sharp turn, they'd actually, you know, this would be your axis, and then it stops. Instead of going straight down, it actually, wow, this is really hard, guys. It actually goes, and instead of stopping hard, it actually oscillates and then goes down like this and keeps swinging as it goes down. So yeah, belts and motors, you know, keep your belts tight. Some printers might not have a way of tensioning them. In that case, well, there are some things you can do. The Malian M150, which is under the desk, I don't think I can pick that up because there's a bunch of stuff attached to it. It actually uses springs on the belts. That's a bad idea, because instead of making your belt system stiff, which you want to avoid those overshoots, you're actually making it tighter, but you're also making it more flexible, which doesn't really do anything. Right. That's belts. That's skipped steps. Yeah, skipped steps obviously on the Fabricator Mini. By the way, how do you like that new shelf? I'm a new shelf in this very strange world. Yeah, the Fabricator Mini actually has some problems with motors getting too hot and stepper drivers needing significantly lower settings than it comes with, and you know, it just has some drag issues where it mechanically has too much drag for the motors to overcome. So yeah, that's the other thing. If your belt is way too loose, then it's going to skip on the pulley. If it's, you know, if your mechanics are too tight and the motor's too weak, the motors are going to skip steps as well. That's the either it works or it doesn't. One more thing, I have a test part of that actually. One more thing on the topic of skipped steps. Trust me, it's not all about skipped steps. There's also a bunch more that can go wrong. But one of the things that can, you know, really get you in trouble are resonances in your machine. So if you look at your motion system, you have your motor, you have your stepper motor, you have the belts, and yeah, that's pretty much it. But that system and the weight on the end, which is, you know, either an extruder or a bed that's being moved around, those actually form a resonating circuit more or less. And if your printer runs into that resonance frequency where it tries to do an infill, like a really fine infill and just goes back and forth really quickly. Some machines with some settings will actually have that turning into a really hard resonance, which, you know, moves your axis much more than you put in as a, you know, as a motion input. It starts resonating and it skips your motor. And yeah, I've had an issue on the, where are they? Right there. Yep. On these drag chains that I printed for my Big Mendel 90, and whoops, these actually have a small section, a small area on the sides here, which just, you know, 2 parameters plus infill makes for really tiny moves. And I've had so many of these just skip, and, you know, halfway across here, I think it was this part in the front here that really set off the resonances of the printer I was using at the time, and just skip the entire thing. And it cost me probably around 2 or 3 kilograms of plastic to figure that out. So please, if you have like mysteriously randomly skipping stuff, keep an eye out for that. I actually have a resonance test which you can use to figure these things out on Umagine. Use that, print that, and if your printer makes funny noises or starts going all over the place, then tune down your acceleration settings and yeah, try to get rid of those resonances. Right, that's that. Yeah, so huge list still to go. Let's see, belt tension, skipped steps. Oh yeah, one more good one, which is actually an issue with a lot of machines. Depending on how the spool mount looks, depending on what filament you use, depending on how the x-axis or the entire kinematic system looks like, and that is the spool pulling up on your extruder. So typically on a system like that, let's get this one into the camera and let's grab a filament spool. Good thing I have so many around here. Let's grab this one. That's why they grab the black filament. Let's grab the purple one. There we go. I still need to get like filament in my CI blue. Right. There's the purple filament. It goes into the extruder like that. And the problem now becomes, let's just clip that right there. Yeah. So as long as this thing is moving around smoothly, we're good. As long as this thing is moving left and right, you know, as it's moving right, it's going to start pulling on this filament and unwind the spool a tiny bit. We're good there. However, the problem is once we're printing like tiny parts that aren't as wide, where the x-axis just keeps moving a tiny bit back and forth, it doesn't pull that filament off the spool as it moves to the side. And at that point, the extruder itself will need to unwind the filament. So we're going to have a force on the filament up, because the filament will need unwinding. It will need that torque to unwind. And that tiny force can be enough to actually, pull the entire x-axis or the entire carriage up by a tiny bit. So yeah, that's something that most printers in this design suffer from. So anything that's built like a Prusa, you know, with a moving bed, the z-axis and then the x-axis stacked on top, every machine suffers from that to a certain amount. I haven't seen it on the Mark IIs yet, I haven't seen it on this one yet, but a lot of other printers that are built similarly will suffer from that. One thing you can easily do about that, let me just grab a Bowden tube from here. Well, a small piece of Bowden tubing just to demonstrate. So this is a 4mm outer diameter and 2mm inner diameter Bowden tube. Essentially what you want to do, obviously this one is way too short. What you want to do with that, why is that filament so tough? What you want to do with that is essentially butt it up against something solid on the extruder and then tie the other end to something solid on the frame. So essentially you're creating what I usually refer to as a reverse Bowden. So the pulling force from the filament doesn't pull up on the extruder, but instead pulls on that spot where you fix that bone tube to the frame. That's one easy fix for that. I see a lot of machines suffering from that otherwise have good print quality. So yeah, that's that one. Obviously bad filament, which surprises me a lot. If you have a look at my YouTube channel, if you're here, you probably know that. I've got Filaween going on, basically a huge filament review series, all with the same tests and stuff. I'm surprised by how consistent PLA filaments are. So I'm seeing very, very little difference between super expensive filament and super cheap filament. However, what I'm seeing on some materials is, well, it will actually print pretty well for like the first 2/3 of the spool. However, as the spool, gets used up, as you're in that last third of the spool, so like the inner part of the spool, print quality will significantly drop because, I don't know, because the filament's curled or just there's something going on there. But yeah, so if you're having print quality issues, maybe try a different spool of filament, same manufacturer. Usually it's, PLA is pretty consistent, pretty good in that regard, but just don't rule out your filament straight away. Right. Let's head over to Twitter and have a look at what people are posting, because this is supposed to be an interactive format. That's why it's live. Let's see. Let's refresh this. I'm hoping you guys aren't posting any inappropriate stuff. Why? Roadlink, why you do this to me? Why you do this? I thought I had unmuted it, but it's like, Thanks for pointing that out, by the way. I just see chat going crazy, and it's like, yeah. Let's try that again. Right, Joachim Eliasson posted this abomination of a benchies. So first off, temperature issues. As always, I'm not making guarantees that the things I'm saying here are 100% accurate. I'm just speaking out of experience and speaking out of things I've seen on prints and I can sort of judge by. So if you got similar issues, these are pointers that will take you towards being able to print better. It's not a guarantee that it's not a guarantee that the things I'm going to tell you are instantly going to make them better, but they're a try. Right, temperature issues. First off, this thing is completely molten down, as you can see by the bow and the chimney, or whatever the official term for that is. It's just too much material too quickly. The stringing here shouldn't be the problem right now. It should be all these little blobs and stuff. So tip for that, turn down the temperature. Try to go with a part cooling fan that actually cools your part, because this thing looks like it's just completely molten down. Once you get that figured out, you know, it's always a step-by-step process. You start with one thing that's the most crucial issue that prevents you from seeing the others. So typically, in this case, it's temperature. It's way too hot. It's no part cooling fan. Yeah, so that should be step number one. So as a makeshift part cooling fan, I've done this before. What you can actually do is you can take a PC fan like that. You know, I've got it pre-wired up handily there. What you can take is just a regular PC fan. This is a 120 millimeter fan, which you can get like for $5 or something. Grab a 12 volt supply. You can actually grab something out of your printer and just place it next to your machine. You know, just like that. And you'd be surprised how much of a difference that actually makes. Maybe try not to blow it too much over the bed, so place it somewhere here. But you know, any sort of you know, airflow will help with something like that. Right, that's a nice first one. It's holy crap. That was done. That was one hell of a start. Actually, what I was saying about the Twitter feed is I'm hoping you guys aren't posting anything inappropriate. I'll try to be careful what I show, but please keep it like safe for the kids watching here. Not that I want to give you guys any ideas here. I had actually seen a good one before we started, so yeah, that's one. I think it was this one, yeah. So, few things with this one. Now down here, actually, can we? Doesn't look like we can actually open it up in full screen or anything. But the main issues with this one are, yeah, you know, the overhang here. It doesn't look that good, but mostly this fine detail here. This is a small part. If we switch over to the A-cam, there we go. I'm hoping I can find where this thing is in focus. There we go. So that's this part back here. That's a relatively fine detail, a relatively small perimeter. Oh, holy crap, this is difficult. And you know, essentially the extruder will need to retract, move over here, then reinsert the filament and start printing again. So what I'm thinking happens here, essentially, if it doesn't go away. Nope. Oh, why did I not click this one? There we go. How to computer. Essentially what I'm seeing here is the extruder does retract properly and then doesn't reinsert the filament all the way. So that might be, again, skipping steps on the extruder. That's also a thing that can happen and can lead to something like this. Retracting, reinserting too quickly, but also like generic issues with the hotend extruder combination. There's a whole bunch of issues that can arise. I think I should mute this. There's a whole bunch of issues that can arise with extruder hotend combinations. One of the things is, you know, what you typically hear talked about with all metal hotends. Especially E3D hotends get a lot of flack for that. I've never personally experienced it, but well, I have recently with a non-genuine part, with like a third-party upgrade part, is PLA jamming, and that is essentially the, let's just grab an E3D hotend. It's not like I have a box of them or something. There we go. So that's a fake, that's a Chinese one. Yeah, that looks good. So typically what's going to happen with these is, God damn it. There we go. Typically what's going to happen with these is, okay, the heater block is heated up and all nice and, you know, cozy for the filament. Then you've got the heat break inside here, and then the heat sink. And ideally the heat sink should be cool. It should be at room temperature, or I don't know, 40 degrees or something. Though what a lot of people are seeing is in the heat break, which is essentially, let me just grab one of those. So these are some of the third-party ones that I was talking about. Does this one have stuff in it? No. So typically this one has a bore that is relatively smooth inside. You might just be able to see that. What will happen inside here is, so this is the end that's hot, that's in the heated part, and this is the cold part. Typically what's going to happen is in this transition zone in the middle here, the filament will get stuck. Because either the surface finish in here is not that smooth, not that good, and also, you know, there might be heat creep going on from the cold or from the hot to the cold zone. So the cold end isn't all that cooled down or cooled down well enough. And that's where PLA likes to jam. And it's, again, that's something where it's on a gradient where it won't really jam all the way typically. It's just going to have some more friction, and that's going to cause extruders to skip. So if you have a look back here, that might be something that's, oh crap, I keep hitting F5, that's what's going on. Yeah. So that might be something that's happening here. So first off, check your hotend. Something else we're seeing here is down here. That is Z wobble. It's not that pronounced here. It's not really something I'd worry about at this point, but we're seeing Z wobble. It's just this regular pattern. You know, this looks like an M8 1.25 millimeter pitch. Just these little tiny things, and Z wobble is hard to really see consistently. So yeah, Z wobble essentially. Let me just, you know, for those of you who aren't familiar with what's happening, let's get this out of the way. I'm just going to sort of explain this on the Wildsmart Mini, because this is the one we have. This one actually has a good system to prevent Z wobble of any kind, but typically what's going to happen is you have a cheap M8 threaded rod for a Z-axis, and those are typically not very straight and also not very highly precisely machined. So this Z-axis rod will, you know, run eccentrical. It will not turn smoothly around a single axis, but it will actually wobble as it turns. And even though we have the bearings right next to the Z-axis nut, that tiny amount of wobble will translate over to the tool head, to your hot end, and it will show up in the print. Surprisingly though, wrong display, well, whatever, it was in the corner. Surprisingly though, even though, now I forgot what I wanted to say. Yeah, so that tiny wobble of the Z-axis spindle will show up in your prints in your nozzle. What? Right, yeah. So surprisingly though, Z wobble will not show up consistently. It will not show up in every part of your print equally. So if you have a look at the, I cannot hit F5. There we go. If you have a look at this benchy again, so it's showing up down here, but not up here. So, and we can also sort of make it out up here. It's like there's one, there's one, there's one, and Z wobble is always in the same pitch as your Z-axis spindle. So this one, which is relatively coarse, I think this is like a 2 millimeter pitch or something. This one, if it had Z wobble, it does not, because it's well designed. This one would have Z wobble that shows up at the exact same pitch as your Z-axis lead screw. So yeah, if we were seeing this on the TAS Mini, it would be a much coarser one. Here it's probably an M8 one. Yeah, but the biggest issue right now that I'd start with is this fine detail. So check your extruder, check your retract speeds, check that the extruder isn't skipping, and maybe even lower the retraction, because you know, if you have too much of a retraction in your slicer setting, then you know you are going to run into issues like I just mentioned with the filament pulling too far back into the normally cold part of your extruder or your hot end and jamming and rubbing there. Right, yeah, better Z lead screws are on the wish list. You should definitely Yeah, Z lead screws are some of the most important things in your printer. You can make your regular M8 threaded rod work. You can make M6 work. You can make a lot of things work, but it's just going to be it's an exceptionally high amount of work for the amount of money you save, and a lot of headaches. So ideally, which ones? Yeah, so the MK2s use Z. I'm just grab one of those. Yeah. So the Prusa Mark II uses motors. Let's switch that over. Uses motors with the integrated Z-axis lead screw. This is a very steep one. This is an 8mm pitch. These are obviously the superb solution. However, these are also sort of expensive. So if you don't want to afford those, you can get solutions like on the Lodespot Mini, where you actually have a proper lead screw again, but then still have it should be visible there. Then still have a coupler there, but then the lead screw supported right here, and I think it's also supported up top. Yeah, that works because this lead screw is straight, and yeah, it comes straight. They buy them straight. They check that they're straight. If these are not straight, if they are were bent, then having the supporting bearing on top and on the bottom would actually amplify that Z-wobble artifacting you're seeing. Yeah, lead screw integrated into a Nemo motor. Yes, you can buy those. They're like, somebody posted 30 quid on eBay. That's roughly accurate. They're a bit more expensive than if you were buying the stepper motor plus the lead screw separately, plus a coupler. The integrated one is a bit more expensive because they're just rarer. But I think they're definitely worth the premium. Right, somebody was asking about over temperature issues. So like this one would probably qualify as a temperature issue, but that's more of a handling issue. This is one of the benchies that I boiled this is one of the benchies that I boiled for Halloween. So if your prints look like that, I definitely check the temperature, and particularly like the temperature of your print environment. That's also something that is important for a whole nother topic of issues you might be running into: bed adhesion and curling. Should we get into that, or should we take another look at a Twitter post? Let me just scroll up here. Right, that one is actually interesting. Okay, let's have a look at this one. So, this one is by... I have no idea what that name is. But he's asking, moiré, is this a moiré artifact? And definitely, yes, it is. Overall, I mean, the print quality on this one looks pretty good. You know, stuff is consistent. You can see a bit of rippling, but that's normal. However, moiré, and this is something... Okay, Google. Wow, I'm triggering phones, not people, thankfully. Yeah, this print looks pretty good. However, this moiré, these lines going up, you know, diagonally, and I'm pretty sure I know what this is. However, it's a very, very rare occurrence, and it's actually like the one argument that people bring out over and over again if they you know, if they want to try to find things against auto mesh or auto bed leveling. So yeah, this one has it. The Prusa has it, this one doesn't, this one doesn't. The printer bot Play has it. Auto bed leveling, essentially where your printer takes measurements of the bed or the bed height at different spots. So the Lodespot Mini does it on the 4 corners. The printable play does it on 4 or 3, I think it does it on 3 spots somewhere on the bed, and then electronically compensates for a tilted bed by moving the z-axis up and down. Now, if you have a z-axis that doesn't do full steps, and I think I have to like to do a bit of a bigger curve there to cover all of that. If you have a z-axis that doesn't move smoothly, then you are going to see buttons. Then you are going to see something like this in combination with auto bed leveling or auto bed tramming tilt compensation. It's not leveling. You don't care about your printer being level. You care about being square with the other axes. Anyways, yeah. What I think is happening here, which I think I discussed in a stepper motor video once. If you have a stepper motor, the stepper motor will have, you know what, let's grab a stepper motor out of the stepper motor box right here, because then I will be able to sort of explain it. Oh, that's a fine-pitched one. We're probably not going to be able to see this that well, but a stepper motor, this is like a typical, 40 Newton centimeter something stepper motor. If you turn the shaft, you will feel click, 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 click. You will feel individual steps, and those are the full steps of your stepper motor. And typically, those are also the ones, well, half steps and such aside, but those are the ones that are like electrically accurate. You got 2 phases in the stepper motor, 2 cores essentially. You energize one and don't energize the other, and it will snap to this full step position. And then you energize the other one and de-energize that first one, and you snap to the first or to the next position. That's relatively rough. That's relatively coarse. So what you can do is micro-stepping. And micro-stepping is sort of a clutch solution where you run your stepper motor like you give it a sinusoidal current shape to make it run less harsh and jerky. So instead of going these individual click, click, click steps, you give it 16 or 8 times or 256 times microstepping. So the driver tries to approximate positions between those full clicks. Some driver motor combinations are better than others with that. Particularly people in chat are writing the DRV8825. The DRV8825 is actually relatively good with microstepping if you're using the right motors. The interesting thing is DRV8825 seem to like high inductance motors as used on the Atom 3D, which is behind the camera right now. Microstepping actually works pretty well there. If you have the Lego drivers plus high inductance motors, then you're getting those sort of artifacts. If you're having the DRV8825 and low inductance motors, then you're also getting those artifacts. So essentially what's happening there is instead of the full steps being smoothly turned into microsteps, you're getting a few microsteps, and then like around the halfway position you get this huge step, this huge snap, where it's moves too far for its proportional for how far it's supposed to go. And I think that is exactly what we're seeing here too. And because with the auto bed leveling, your z-axis isn't actually aligned to the layers, so the z-axis is actually moving up and down. This might be just what's happening there. So either first off, try without z-leveling. That would be a good indication of what's actually going on there. And if it is actually a microstepping issue, then try different motors, try different stepper drivers, try different current setting. That might also help. How do you determine stepper inductance ray Shine is asking in chat. It says on the motor datasheet, just compare it to a few different ones. So typically a high current motor, like if you have, did I put it away already? Yeah. So if you have motors of the same size, these two obviously aren't the same size, but if you have the same size motor with a high current, that's going to be a low inductance motor. So a I think this is a 40 millimeter type. If this one would have a 2 amp or 2.5 amp rating, it would be a low inductance one. If it were a, say 0.5 amp or 1 amp motor, it would be a high inductance one. Just made, the high inductance ones are typically made for higher drive voltages, and the low inductance ones are made for lower voltages. Right. Very good. Yeah, someone's asking about E3D V6 clones or non-clones or genuine ones in chat. Please, guys, I keep saying it. Actually, let me grab one. That's a V5 clone. Let's get the genuine V6, V5. That's a bastard V6. So that's my first E3D hotend. Wow. Let's actually compare these two. Just, because people are going to run into print quality issues, so it's sort of fitting as well. These are two hotends that look very similar. Oh, this one is unthreading itself, obviously. These two are two hotends that look very similar on the surface. However, if you look here, there is a striking difference. There we go. So this is actually my first. This was the first E3D hotend that I bought. It's a V4. It's a 3 millimeter version. So yeah, the old one, no Bowden coupler in here. Still the big old heatsink, Captain tape thermistor, obviously. So yeah, this one worked. This one still works. I've been really happy with this one, and it's probably the one reason why I keep recommending the E3D stuff so much, because this one just works. This is a clone. This is a V5 clone. And this is exactly as it's been, as it's been delivered. First thing, the heat break right there. This thing is going to have jamming issues. I guarantee you, because what they forgot to do is actually machine the end of the heat break here. It doesn't screw in all the way. They deliver it like that to you, and they're like, yeah, here, that's a V5 hotend. There you go. That's as far as it will screw in. Just compare that to the original. That's just not a sharp thermal break. And everything up here, everything where the thread is starting, it's just going to have a very, very weird and undefined temperature profile, and that thing is going to jam. And I think a large part of, hey, my E3D is jamming, is coming from clones that are not well machined, and that are just subpar, even if they look the same on the outside, which this one obviously didn't. They do have a very different surface finish on the heat break, particularly on the inside. Right, that's that. Why was I talking about that? Yeah, because someone asked. Sweet. Let's move on to Twitter and let's have a look at another print. Let's actually refresh the page. What is that? I think this part is supposed to be like that. That's supposed to be support material. Sorry, that was loud. I just bumped the microphone. I think I saw one that was, yeah, okay, so this one obviously printed on the Print About Simple metal. That is a very, very classic example of Z-wobble. Now, Z-wobble might actually manifest in two different ways. It might actually manifest in the, I'm hoping that the little image in the corner of me is clear enough. It might manifest as like the layers actually moving in a spiral pattern, so just on the XY plane moving up. That's the good way. The way that's, just gonna have the way that's gonna have the layer shifted, but not much of an impact otherwise. What might also happen is once you have your Z-axis spindle actually tilting, that might actually push up. You got your nuts, your Z-axis nut, and you've got the thread to it on the threaded rod. Once that starts tilting, and once it starts tilting back and forth, you can see how these teeth might actually engage on the top and push it up, and then on the bottom push it down. that might cause some really, really tough issues, not only with that spiral pattern, but also with the layers not moving up in a consistent fashion and splitting and doing all sorts of crazy stuff. So yeah, to get back to this one, this is very definitely Z-axis wobble. The printer board Simple Metal, I think, works very similar to most other printer boards where it has that, I think it actually has a flexible coupling. But in that case, maybe just show that coupling for a second. So the play actually has a rigid coupling in here, right there. That coupling down there. Readjust it, just tighten those grub screws, and play around and see which position is going to work better for you there. And now my OBS Studio is full screen. Great. Right. So the lines on the ship's sides. Oh yeah, this is nice. So as you can see, these lines right there, and this line, and that line, and this one. Otherwise, really nice bench actually. Overhangs really nice there. The surface quality looks pretty good. There's actually a bit of curling here. So the first of the heated bed might be a bit too hot. But those lines, these are the lines where the extruder actually starts extruding. That's what an extruder does, right? This is where the extruder starts extruding after a retract. So it actually retracts somewhere. Well, that's the nozzle. It pulls the filament out of the nozzle, moves somewhere else, and then reinserts the filament into the nozzle. What's happening here is it actually ends up extruding too much. So it's, extruders, hotend, that sort of stuff is really complex. I can't tell you how to get rid of it. I can't really explain why it's happening in all like the fluid dynamic details. But what you can typically do to get rid of something like that is, first off, lower your retract settings. So direct drive extruder, the Prusa Mark IIs are actually set up with 0.8 millimeters, which is extremely low. Typically like below 2 millimeters, 1.5 or something, I'd say would be a reasonable retract length for a direct drive extruder, maybe 4, 5, 6 millimeters for Bowden, depending on how the Bowden is exactly set up. But in that case, lower the retracts, because I'm seeing no stringing right there, nothing in that case or in that matter at all. So yeah, lower the retract settings, plus most slices actually have a extra length on restart setting. Let's see if I can quickly pull this up on the Slick 3R build here.